So I got a question from a Calculus 2 student about what would be some good problems from Chapter 7. One of the things that Chapter 7 really helps us do is to learn how to set up an integral that represents a real world problem, okay? In other words, what are the pieces of the integral and where are they in a particular problem? So some of these pumping problems do that pretty effectively. So an example is this thing where we have, a circular tank, right? And we can give this thing some dimensions. I don't know, we can say it's 6 feet radius and maybe it's 8 feet deep. Okay, and it's a right circular cylinder, just a tank full of some kind of liquid. We can give it a density. Doesn't really matter. 60 pounds per cubic foot. So that's the density of the liquid in there, right? And so say we want to pump this stuff out to a level that's, I don't know, let's make it 10 feet above the top of the tank. So in other words, we have some kind of a pump in here, and the pump is going to discharge here. It's going to pump this tank out. Let's say the tank is full of this fluid, okay? Okay, so how are we going to do that? Well, as we pump this thing out, okay, first of all, understand that when this tube, this discharge tube from the pump goes in here, right? Let's assume that this pump doesn't block the flow of fluid through it when it's off. So what's going to happen is the fluid's going to flow into the pump and it's going to flow up to here, and it's going to have this level, the same level as the top of the tank, in this tube, okay? That's important because this is actually the fluid that we're going to start lifting, right? So when we start lifting our fluid, how far are we going to lift that fluid? Well, we're going to lift it 10 feet, right? And then as the tank drains down, okay, and becomes, empty, let's assume that we can completely remove all the fluid from the tank. This last sort of like a layer of fluid, right, is going to be raised how far? It's going to be raised 18 feet, right? So the distance that we're going to move our fluid, okay, let's just call it, since it's vertical, everybody wants to call that y. So let's say that it's going to go from 10 to 18, and there it is, okay? So this is now the distance that I'm moving my fluid, okay? This is my distance. That's what that represents, okay? Now, we want the work required to pump this fluid out. That's what we're after. And work is force times distance, okay? It's a pretty simple relationship. So we got the distance. All we need now is the force, and we're good, okay? Now, force, pounds force, okay? This is going to be volume times density, okay? So the question is, what is the volume that's actually being raised 10 feet? It's not 0, right? Because, if it were 0 times 10 would give us 0 work, and we know it's going to take work to pump this fluid out, right? And yet, any amount that you give it, if you say that it's an inch or it's a half an inch or whatever, of a change of level in the tank, this somehow doesn't seem to work because this is a continuous flow process, right? So because of this continuous flow process, we have this idea of an infinitely thin layer of fluid here, okay, very, very thin layer that's actually being raised to 10 feet. And since this is our y-axis, okay, this is going to be the infamous dy, okay? Now we can get a volume, okay, because we know that the volume of this disk is going to be pi r squared h, right? So that's going to be pi r squared H. Yeah? Notice that our radius is constant in this particular tank, right? It's a right circular cylinder, so it has a 6 foot radius all the way to the bottom, yes? So this is 36 pi, so the 36 pi actually is a constant and it can stay out here, all right? And what we have inside here is just the dy. So we end up with a pretty simple integral, okay? Oh, but the density's missing, right? Yeah, okay. So you're going to have some kind of a density out here. Okay, so the density is constant in this particular problem. So this is how this is set up. Okay, now this is your distance, and this is actually a component of your force, right? This is the other part of your force. So this is the force times distance, and that gives you the work. I'll make another little video where we're working on a different shape, but this is all I wanted to show you right now.